Welcome to the Explainer. Today, we're going on a bit of a journey. We're going to follow a single line of code, literally from a developer's laptop, all the way into a live production environment. But before we get into the nitty-gritty of how that works today, let's take a quick trip down memory lane. Think back to the not-so-distant past of software development. You know the vibe, that classic throw-it-over-the-wall-to-operations mentality. A developer finishes some code, drops the infamous, well, it works on my machine excuse, and just hands it off. From there, it was basically a manual, stressful headache just waiting to happen. Today, we're exploring how DevOps automation completely flips that script. We're talking about transforming software delivery from a terrifying game of operational roulette into a seamless, highly efficient pipeline.
So, imagine this for a second. What if your software deployments took minutes instead of hours or, even days? Just paint a quick picture in your mind of that dreaded, messy weekend deployment. We've all heard the horror stories. Heck, a lot of us have lived them. It's 2 a.m. on a Saturday, engineers are running on cold pizza and sheer panic, desperately trying to figure out why some manual server tweak broke the entire app. Now, what if you could just eliminate that system downtime? What if you could erase human error from your delivery process entirely? It sounds like a total pipe dream for anyone who survived a 2 a.m. war room, right? But for the absolute best engineering teams out there, this level of frictionless delivery is actually just a normal Tuesday.
Okay, let's dive right into this. According to the Accelerate State of DevOps report by Dora, 26% of software teams are now officially classified as elite performers. But what actually makes them elite? Well, it's not just about moving at breakneck speed. It's about combining incredible velocity with bulletproof stability. These elite teams have drastically slashed their lead times for getting changes into production, but get this, their failure rates are actually way lower than their slower competitors. They aren't just working harder or typing faster. They're working fundamentally smarter by relying on automation as the absolute backbone of their software delivery. They don't sacrifice safety for speed. No, they use automation to guarantee both.
Section 1. The CI/CD assembly line.
So, elite teams achieve this crazy velocity by treating software delivery exactly like a highly tuned automated manufacturing process. At the core of that process is the classic DevOps infinity loop, driven by continuous integration and continuous delivery, CI/CD. Think of continuous integration as the ultimate unforgiving quality control inspector on the factory floor, meticulously checking every single bolt and weld. Every single time a developer commits code, boom, it instantly triggers a build and runs a comprehensive suite of automated tests. If it passes, it moves straight to continuous delivery, which is basically an automated conveyor belt, seamlessly shipping the finished product right to its destination. This continuous, unbroken cycle entirely replaces that clunky, manual coordination that historically bogged down releases. Now, to keep this rapid flow moving without breaking things, teams adopt a core philosophy called shift left. Traditionally, organizations operated on a shift-right mentality, basically waiting for real-world failures from actual users in production to figure out something was wrong. Not ideal. CI/CD allows us to shift left, literally moving our testing and security checks as early in the timeline as possible. Let's use a concrete example here. Instead of waiting, say, 3 weeks for a dedicated QA team to find a memory leak during manual testing, the automated pipeline flags the exact line of bad code the minute the developer hits save. We're catching bugs and vulnerabilities incredibly early in the cycle, long before they ever get near an end user. And to truly understand why shifting left matters so much, you've got to look at the math. This data from the Ponemon Institute is wild. Finding and fixing a defect during early development costs on average around $80. But if that exact same defect slips through the cracks and makes it into a live production environment, that cost skyrockets to $7,600. I mean, that is almost a 100-fold increase just because one little bug traveled too far down the pipeline. So you see, automated early testing isn't just some engineering flex about moving fast. It has a massive, undeniable financial impact on the business. Catching errors early stops the cash burn on firefighting and actually frees up your budget for real innovation. To power this whole highly efficient assembly line, DevOps teams rely on a specific stack of tools. And they all work together like a brilliant logistics network. Think of Jenkins or GitHub Actions as your air traffic controllers, right? They oversee the whole operation and tell the other systems what to do. They command Docker to securely package your app into a standardized, lightweight container. Then, Kubernetes steps up as the cargo ship captain, intelligently moving, managing, and scaling those containers wherever they're needed.
And Terraform? Well, Terraform is essentially building the docks, the ports, and the infrastructure on the fly to support the whole shebang.
Moving on to Section 2, Infrastructure as Code and DevSecOps.
Okay, so now that our code is tested and packaged, we obviously need a secure environment for it to live in. And this brings us to our 5-step automated workflow. Step 1, the code is committed. Step 2, it's automatically built and tested. Then things really speed up at Step 3. Infrastructure as code automatically provisions the exact servers and networks required. Step 4 triggers the automated security scans. And finally, Step 5 handles deployment and monitoring. Walking through this, I want you to notice what's completely missing here. Human intervention. Zero manual server configuration. The dark days of a deployment failing because someone said, "Oops, I forgot to open that one specific firewall port," are completely, officially over.
The real secret sauce here is managing the resource lifecycle through infrastructure as code, or IAC. With tools like Terraform, your entire infrastructure is defined as text files. Nobody is manually clicking around cloud provider consoles spinning up servers. And this solves a massive historical problem called configuration drift. Think of configuration drift kind of like an old family recipe passed down through generations. Over time, Uncle Bob adds a pinch of this, someone else adds a dash of that, and eventually the dish tastes completely different. Manual servers do the exact same thing as different admins tweak settings over time. IAC forces the exact same automated recipe every single time, guaranteeing your environments are provisioned perfectly.
Because the infrastructure is actually written in code, it completely unlocks the power of DevSecOps, specifically compliance as code. We can literally hard code strict security and regulatory rules directly into this automated flow. Think about the traditional nightmare of security audits. There's no more waiting 3 agonizing weeks for a security review board to manually approve a deployment. No way. The pipeline automatically scans for vulnerabilities and compliance violations during the build itself, giving developers immediate actionable feedback. It takes security from being this traditional, annoying choke point that slows everything down and turns it into a built-in enabler of speed.
Section 3, Self-Healing and Rollbacks.
All right, we've safely crossed the deployment finish line. But listen, the automation absolutely does not stop once the software is live in production. Even with elite testing and flawless infrastructure, weird things happen in live environments. That's why an automated rollback is absolutely critical. Think of it as the system's neurological reflex. Imagine a scenario where a newly deployed feature suddenly causes your server CPU to spike to 100%. The system doesn't wait for a human to wake up to a blaring pager alert. Nope. It instantly, automatically rolls the application back to its last known stable state, which means your developers actually get to sleep through the night while the system protects itself. It's brilliant.
This level of operational safety is powered by a continuous planning, monitoring, and evaluation cycle. Continuous monitoring tools are always capturing logs and performance metrics from the live app. But the cool part is, they don't just store this data in a dashboard for someone to look at later. They actively feed it into a self-healing infrastructure. The system evaluates metrics like latency and error rates in real time, completely closing the loop between operations and development. By intelligently analyzing this data stream, automated systems can proactively spot anomalies, route traffic away from failing nodes, and deploy fixes. Often, it completely resolves an issue before a human user even notices a glitch.
Finally, Section 4, the modern software backbone. When we combine all this, continuous integration, infrastructure as code, automated security, and self-healing environments, we fundamentally transform how an organization operates. And the real-world results? They're just undeniable. Let's look closely at a recent analysis of an automated testing and deployment framework. Check this out. Test execution time dropped by over 37.5%. Deployment success soared to a 96% reliability rate. When things did occasionally break, automated rollbacks time was 50% faster, which culminated in a massive 66.7% reduction in overall production downtime. Just take a second to let those numbers land. This data proves, definitively, that DevOps automation isn't just some IT buzzword. It's a highly measurable business strategy that brings unmatched speed, consistency, and scalability to literally any team. So, what does this all mean? Ultimately, it represents a profound mindset shift for modern technology teams. DevOps automation is no longer an optional upgrade or some luxury reserved for the massive tech giants of the world. It's the absolute foundation for reliable, modern software delivery. By embracing these tools and concepts, from that CI/CD assembly line we talked about, all the way to automated infrastructure provisioning, organizations can transition their most valuable asset, which is their engineering talent, away from mundane, repetitive server management. Instead of running around putting out fires, your teams can focus entirely on engineering velocity, building awesome new features, and delivering continuous value to your users.
Thank you so much for joining me on this journey through the DevOps pipeline. Before you go, I want to leave you with one final provocative question to challenge how you're currently doing things. Are you ready to stop managing servers and start engineering velocity? If this explainer helped you grasp the incredible power of automation, please hit that like button, share this with your colleagues who might still be stuck manually deploying code, and definitely subscribe to the channel for more deep dives into the strategies driving modern tech. See you next time.